All right, everybody, this is 5-5, day 2. We're going to talk about the half angle formulas today. So this is just the exact opposite of the double angles we were working on before. So you're going to need to have your trig identity sheet out so you can do some adding of things onto that as well. So how you get the half angle formulas is taking what we did before, double angle, and just solving for the other angle. So I'm going to derive one. So this is not in your notes already, but we're going to take a look at this example of one of our double angle formulas from the other day. So this is solved for cosine of 2u, meaning the double angle. And in the other side is this cosine of u. So I want you to look at the relationship between the two angles. The relationship between 2u and u is that 2u is twice as big, right, as whatever angle u is. Or you could say that the u is half as big as 2u. So whatever u is, 2u is double, so it's half the size. So in order to get a half angle formula, where that comes from is just taking these relationships and solving for the other variable, putting it in the perspective of the smaller angle. So I'm going to solve this equation for cosine squared of u. So I'm going to add the 1, get that on the other side. So we have 1 plus cosine of 2u equals 2 cosine squared of u. And then to undo that times by 2, I'm going to divide by 2. And I'm going to have already my equation solved for the cosine squared of u. What that's allowing me to do is I'm going to be solving this relationship for the angle that's half as big. We're kind of on our way towards getting these half angle formulas. So cosine squared of u then is 1 plus cosine of 2u over 2. Now you can do a very similar thing to solve for sine squared. So I'm not going to derive that one. I'm just going to give it to you. So 1 minus cosine of 2u over 2 is sine squared. Now in order to get tangent squared, tangent, remember, is sine over cosine. So tangent squared would be sine squared over cosine squared, which means taking these two fractions and dividing them. So just kind of scratch work off to the side here. You don't have to actually do that work, but this is what you'd be dividing then, right? We'd be dividing these two, multiplied by the reciprocal. The 2's are going to divide out, and you're going to be left with 1 minus cosine of 2u over 1 plus cosine of 2u. These are called power reducing formulas because you're trying to solve for that, that other angle. So all of these are just coming from the original functions that we did for double angle and just solving for the other variable instead, the one that's half as big. Well, oftentimes though, we don't want what sine squared is, right? We just want sine or just cosine or just tangent. So to get to that, all we have to do then is square root each side. So I'm not going to have you do that right on your note sheet so you get that all messy, but I'm just going to kind of do the work off to the side here so you can see what happens. So we have sine squared equals 1 minus cosine 2u over 2. I'm going to square root each side so I can get the expression just for sine. Now if I do that, remember when you square root, two answers, right? Plus or minus, and then we have the square root on this side. Now I want to direct your attention again to the relationship between the angles. So the relationship between the u and the 2u, once again, the u is half as big as what 2u is. So we're solving for the one that's half as big. That's why they call these half angle formulas. Now instead of writing it like this, so the textbook does make a replacement, and they're going to write it like this, and pretty much universally you're going to see this. I want to see if you can tell what I'm changing here to be able to see what's going on. So instead of writing sine of u, I wrote u over 2. And instead of writing cosine of 2u, I wrote cosine of u. But I want you to look at the relationship again between those two angles. U over 2 is half as big as what u is. So that's that half angle formula. So the relationship between the two is the same. They make that substitution, I think, just to make it super clear that, hey, this is a half angle formula. So that's how it's written. But those variables could be anything. As long as what's under the radical is twice as big, it's a half angle formula. So we can actually write those out. So we get these half angle, these alternate forms, by replacing that u with a u over 2. And that u over 2 then becomes that half angle. That looks terrible. Can't even read that myself. So that becomes the half angle formula then that we're going to talk about. So for the sine, if we did that square root, that's one we already talked about. That would be square root of 1 minus cosine of u over 2, plus or minus, remember. And again, if I went back to the last one and I square rooted the next one, you would get the same sort of thing. So we'll write that one in. So cosine of u over 2, plus or minus. Again, when you square root, 1 plus cosine of u over 2. Notice the only difference between the sine and cosine formulas are the signs under the radical there. Now for tangent, I'm going to go back to the original here. When we square root both sides for tangent, you get the square root of a fraction, which you have to rationalize, and you can do some substitutions. And what you end up getting are two different versions for tangent. We actually can do 1 minus cosine of u over sine of u, or we can do sine of u over 1 plus cosine of u. This comes from, again, rationalizing and doing some substitutions. You get down to two different options. So we're going to talk about different choices that we might want to make depending on what the numbers are. Okay, these are the ones that I need you to add onto your trig identity sheet. They have the power reducing up at the top, but you don't have this version on the note sheet. So if it's not there, please make sure you copy this onto your trig identity sheet. So you need to add this to your trig identity sheet. So take a moment, pause the video, make sure you put those in there so you have that on your sheet. Once we're actually using these formulas then, the plus or minus out front, we have to talk about that because we need to be able to decide, is it positive or is it negative? Well, the sign of this cosine or sine answer always depends on what? What do we always have to look at to see if sine or cosine is going to be positive or negative? You always have to look at the quadrant, right? So where is it? So we need to look at the quadrant for that u over 2 angle. Whatever quadrant it's in, that will determine whether it's going to be positive, negative. For example, if u over 2 is in quadrant 2, then sine would be positive and cosine would be negative. So it depends on the quadrant in which function you're doing. So we'll have to look at that each time. All right, so there's three big things then that we're going to do with these half angle formulas. The first is, what about these non-special values? Is there a way that I can actually come up with something that's not a special value using a half angle formula? So let's take a peek and see if we can do that. So tangent of 15. 15 is most definitely not a special value angle. If we were doing this in sum and difference, I would ask you to come up with two angles that either add or subtract to give you 15, like 45 minus 30 or 60 minus 45, and it works great. We can use a sum or difference. But we can also use now a half angle, because if this half angle is 15 degrees, so the u over 2, what would the u be? What would double it be? Well, 30. And 30 degrees is most certainly a special value angle, so I can use that half angle formula. Now for tangent, we have some options, though. Remember, there's two different choices. So we may want to do a little bit of thinking ahead at which of these options, number 1 or number 2, might be easier. So let's think about what we know. So let's think about sine and cosine values for 30 degrees. Sine of 30 is a half. Cosine of 30, what's cosine of 30? Square root of 3 over 2. So think about where you'd want those numbers. So as you look at number 1 versus number 2, the formulas, number 1 has a sine of u in the bottom, which would be a half. That means you'd be dividing by a half. Well, to divide by a half, you multiply by the reciprocal. That'd be times by 2. That's pretty easy. Over here, you're going to have a radical thing in the bottom. Square root of 3 over 2, which you're eventually going to have to flip, which means you're going to multiply by the reciprocal. You're going to have a radical in the bottom. Yucky. Very good mathematical term, yucky, right? So it's not a great number. So to kind of plan ahead and think about what might be better, I think number 1 might be a better option. Can you get the same answer both ways? Sure you can, but it might take you longer. It might have a little bit more work to do. So I think this is probably a little bit better option for us to be able to use. All right, so let's go ahead and write that out then. So tangent of 15 degrees would be 1 minus the cosine of 30 degrees over the sine of 30 degrees. And then I'm going to do that arithmetic. So we have 1 minus square root of 3 over 2 over 1/2. We need to get a common denominator up top, so we follow order of operations. So I got to put those together. So 2 minus square root of 3 over 2 over 1/2. We've got dividing two fractions, so we need to multiply by the reciprocal. So we're going to multiply by 2 over 1. The 2's will divide to 1. And we're left with 2 minus square root of 3 for our tangent of 15. Now what I'd like you to try on your calculator is type in tangent of 15. Make sure you're in degree mode on your calculator. And then also type in this, 2 minus radical 3, and see what you get. Your decimal equivalent should be exactly the same, so they have the same decimal. What's better about this? That's an exact answer, right? We don't have to round, and it's exactly 2 minus square root of 3. If we would have done the sum and difference version, that 45 minus 30, you would have gotten the same answer. It's just another option available to you. All right, let's try one more of those. I'm going to have you add this one, cosine of 105. So again, not a special value angle. However, we could have done it with the sum or difference. So can you think of two angles that either add or subtract to 105 that are special values? So maybe you're thinking about 60 plus 45. That would have worked. What about we could have done 150 minus 45. Got lots of different choices. But how about instead thinking of it as a half angle situation? So the 105 is the u over 2. What would u be? What would double it be? Well, 210, is 210 a special value? Absolutely. So we'd be able to solve using that half angle formula. So I'm going to go ahead and write out the formula. Cosine of u over 2 plus or minus square root 1 plus cosine of u all over 2. All right, so what are we going to do with this? Well, let's see what we can do with this quadrant first. We're trying to find 105. 105 is in quadrant 2. Okay, what do you know about quadrant 2 for cosines? Well, cosine is x, so it's going to be negative. That's how I tell whether I take the positive or the negative here. I go by the original angle, that u over 2, the one I'm trying to solve for. That's going to have a negative value because cosine in quadrant 2 is negative. So we got to figure out the sign. Then we go ahead and put in our angle, our u, which is 210 degrees. And then I just need to figure out what that value is. All right, so we've got negative out front. 1 plus cosine of 210. So 210, that's in quadrant 3. So cosine is going to be negative. That's a 30-degree reference angle. So what's cosine of 30? Root 3 over 2. So it's negative root 3 over 2. Everything from here on out is just arithmetic. It's not great arithmetic, but it's just arithmetic. Our trig part of this question is done. We need to get a common denominator. So we've got 2 minus square root of 3 over 2. And then all over 2. All right, now, again, think of that denominator as a fraction, 2 over 1. We've got to multiply by the reciprocal. So we've got 2 minus square root of 3 over 2 times the reciprocal of 2 over 1 would be 1/2. In that last question we did, the 2's divided out. They won't in this one. They actually multiply together to give you 4 in the bottom. So we have 2 minus root 3 all over 4. Now for radicals, remember you can simplify the top and the bottom separately, so we can do work on the top and the bottom. I think the only thing we can do is that, the square root of 4. So we get on the numerator 2 minus square root of 3 all over whole number 2. Now I'm being a little bit crazy with my division line here, but make sure you're very clear. The only thing that is in the denominator is just the 2, the whole number 2. No radical down there. We did that special value. Again, check with your calculator. Type this in, cosine of 105. Type in that radical divided by 2. You should get the same decimal equivalent. They're the same value. So one of the big things that we can do with these half angle identities, just like our others, is we can find the values for things that aren't special, because we can use double the angle that we do know. Okay, well, another big concept that we've done is solving equations, being able to solve equations using these identities. So here's the equation that we're going to solve in this interval. So we're going to solve cosine squared equals sine squared of x over 2. So cosine squared of x equals sine squared of x over 2 in the interval 0 to 2 pi. So remember what the interval 0 to 2 pi means. Are you going to have infinite or finite answers? Well, it's going to be finite because you're just listing them. There's no plus 2 pi n. There's no all the coterminals. It's just those angles. All right, so let's take a look at the functions we have. So remember, when we're trying to solve, always identify what do I know? What kind of functions do I have? What do my angles look like? First thing I notice right away is there's sines and cosines, so they're not the same. The functions aren't even the same. But even worse, in my opinion, is look at the angles. You have an x and an x over 2. They're different. One of them is half as big as the other one. So when I'm looking at this, gosh, I'm not going to be able to solve for this. The angles are different. So I want to bring you back to what we were doing before when we were solving trig equations. If something is different, if something is not the same, what do we do to try to make them the same? We can't solve unless they're the same. We need to substitute. You have to replace. Well, now we have more options that we can substitute with. So I'm going to take a look at this right-hand side. We have sine of x over 2, whatever that is, that quantity squared. It might be a little bit easier to think of it that way. So sine squared of that, or sine of x over 2 squared. I think we have a formula for this. Isn't that what we were just doing? Sine of x over 2. So if we go to our half angle formulas, we have a relationship for that. I'm going to replace it because then I can try to make those functions the same. So sine of x over 2 is 1 minus cosine of x over 2, square root, and technically plus or minus. And that expression is squared because, again, this side of the equation is squared. Now let's take a look at what that gives you. Well, look, everything's in cosine and everything's in x. We have the same angle, same function. I'm going to be able to solve it. Even better, what happens if you take a square root and you square it? Opposite operations, they undo each other, right? They are inverses, and all you're going to be left with then is this relationship underneath. So we get that 1 minus cosine of x over 2. Great. Okay, so what degree equation do you have? Well, it's degree 2. How do we solve degree 2 equations? We solve by factoring if it does, otherwise quadratic formula. What might be bothering you, though, a little bit on this one is it doesn't look super great to start factoring because of that 2 down there. So how do we undo dividing by 2? We multiply by 2 on each side. So we don't want a fraction in there as well. So let's deal with that first. Okay, what do you want your equation equal to if you're going to solve by factoring? 0. So let's move that over. So 2 cosine squared plus cosine of x minus 1 equals 0. Okay, and then we're going to go ahead and factor. So we got 2 cosine of x, and then looks like to get a negative 1, we need 1 and 1, and I think we want the plus here and the minus there. Check your OI. Outsides you get negative or positive 2, insides negative 1. That definitely adds to 1. All right, so let's set these equal to 0 and solve. So when is cosine of x equal to a half? Well, cosine is a half at 60, or pi over 3. That's in quadrant 1. When else is cosine positive? That would be in quadrant 4. So 300, or 5 pi over 3. And then when is cosine equal to negative 1? Well, that happens at pi. And remember, this isn't all values. It's just 0 to 2 pi. So we have that finite list of answers. So we can solve equations. Everything that we did after that initial substitution, so everything kind of from here down, from this red version down, that's all just solving, and we've been doing that all the way through. So it's no different. It's just we have another substitution we can make because we have this half angle identity to look at. So moral of the story, if something's different, try to make them the same, right? So we'd be able to simplify and do what we need to do. Okay, so last thing that we're going to talk about, last example we're going to do, what if you know something about a triangle? So that's what we're going to do last. So what if I have some information about a triangle? So I am giving you this. So remember, if I give you a trig ratio, you know 2 sides of a right triangle. If I tell you this, you know where that triangle is going to be. So if we're between pi and 3 pi over 2, where are we sitting? Well, that would be quadrant 3. Okay, what do you know about things in quadrant 3? Let's go ahead and draw this triangle. What do you know about x's and y's in quadrant 3? Well, they're both negative. So in SOHCAHTOA, tangent is opposite over adjacent. So I know that this is going to be 8 and that's going to be 15. Picture, not to scale. But what do you know about both the 8 and the 15? If we're in quadrant 3, those both have to be negative because x and y are both negative in quadrant 3. Okay, now you can find your third side. So 15 squared plus 8 squared. So 225 plus 64, that's 289. So 17. Now you can find anything you want in that U triangle. So let's try the first part. We're going to do sine of u over 2. I'm going to write out the formula first. So plus or minus 1 minus cosine of u over 2. Okay, so our first order of business is we have to figure out, is it plus or is it minus? Let's take a look at the angle. U over 2. We got to figure out what quadrant that's in. All right, so if you take a u angle that's in quadrant 3, an angle in quadrant 3, and divide it by 2, where would you end up? Well, if you're in quadrant 2, the biggest your angle could ever be is just about 270, but not quite. Half of 270 is 135. That puts you in quadrant 2. If you take half of the smallest angle it could be if you're in quadrant 2, the smallest it could ever be would be just a little bit bigger than 180, right? Like 181, something like that. If you take half of 181, you're at like 90.5, which also puts you in quadrant 2. No matter what you do, if you take a third quadrant angle and you cut it in half, you're still in quadrant 2. So what does that tell me for sine then? It's going to be positive because sine is y. That's what you're going to have to do. You got to figure out, where's my angle? My original u over 2 angle. Where is it? That's what's going to tell me if it's positive or negative. The rest of this, we're just going to use the triangle. So 1 minus cosine of u, cosine of this angle. So cosine is adjacent over hypotenuse. So negative 15/17, and then all over 2. All right, we got some arithmetic to do, but that's the easy part, hopefully. Fingers crossed. So square root of, let's get common denominator plus positive. So it looks like we've got 32 over 17 divided by 2. And then we're going to multiply by the reciprocal. So 32 over 17 times, remember that 2 over 1, reciprocal would be 1 over 2. I think we can simplify down a little bit here. So 1 and 16, so 16/17. Remember, in a fraction, taking the square root, we can do the top and bottom separately. So think of it like this, square root of 16 over square root of 17. So 4 over the square root of 17. And then we can rationalize. So 4 square root of 17 over 17. The arithmetic's a little hairy, but we can handle it. All right, now the nice thing is, though, cosine of u over 2, the arithmetic is almost identical because we have 1 plus cosine of u over 2. So it's going to work out very similarly when we do this solving. But again, let's talk about the plus or minus part. Remember what we said about u over 2, that it's in quadrant 2. So what do you know about cosines in quadrant 2? Well, they're negative, so that means this answer's got to be negative. So just be really aware of where that original angle is. So the cosine of 2, or u over 2, is going to be negative. And then we have 1 plus our cosine ratio. That was negative 15/17 all over 2. All right, then we got to do our arithmetic. It's almost identical, though, right? It's just going to be negative out front. The sign is different. So we get a common denominator, so 17 minus 15, so 2 over 17 divided by 2. Then we've got to multiply by the reciprocal. Oops, still negative out front. That's real easy to do, so make sure you keep carrying your negative through. So 2/17 times reciprocal of 2. Well, that would be 1/2. So I can simplify a little bit, divide those 2's out. So we get 1/17, still negative. And again, remember, you can do the top and the bottom separately. So the square root of 1 is 1. Square root of 17 is 17, square root of 17. And then we rationalize. So square root of 17 over 17. So sine and cosine, the arithmetic's almost identical. All right, let's try tangent. So tangent of u over 2. Remember, you have your two options for your equations. And again, my personal preference, depending on what I'm trying to do, I often like the first one, and especially in this situation where there's no radicals, I probably would just do that. So I think I'm going to use the first one. Feel free to use either one, though. It doesn't make any difference at all. So 1 minus cosine of u over sine of u. So we're just going to grab those ratios from the triangle. So 1 minus negative 15/17 was cosine. If we go back to our triangle, just to peek here, sine of this angle, sine, SOHCAHTOA, opposite over hypotenuse, so negative 8/17. All right, just a little arithmetic on this one to finish her off. So common denominator plus positive. So we've got 32/17 divided by negative 8/17. And I think this is going to work out pretty darn nice. So we have 32/17 multiplied by the reciprocal. So 17's divide to 1. And then 32 divided by negative 8. Yay! A nice number. We haven't had a whole number for a while, an integer, negative 4. Now remember, what you could do also to find tangent. We know our answer for sine and for cosine. We could have just divided those two, right? So we could have taken the answer for sine, the answer for cosine, and just divided them, and we could get that. Now, I would never advocate finding sine and cosine with these long formulas just to find tangent. If all you want is tangent, do the tangent formula. But if you already have sine and cosine, Absolutely great to just go ahead and divide those two numbers to see what you have. All right, so we're doing these half angle formulas. So remember the idea with a half angle? We took the double angle and just solved for the one that was half as big. That's where they come from. So they're great for solving equations to make angles the same. They're great for using identities when we know stuff about triangles. Also great trying to find out an angle that's not a special value if you know double it, the half angle formulas.